Section 1 is simply working with sequences and terms in a sequence. If the numbers in a list follow a pattern, you may be able to write a rule for the pattern. That's what this chapter is all about, writing rules for patterns. A sequence is just an ordered list of numbers. An ordered list of numbers could be 1, 2, 3, 4, and so on. It could be 2, 4, 6, 8, and so on. It could be 1, 1, 2, 3, 5, 8, and so on. Just an ordered list. The term of a sequence is each individual number in a sequence. So this is a term, this is a term, this is a term, this is a term, this is a term. Each individual number is its own term, which means we could call this term number 1, term number 2, term number 3, term number 4, term number 5. We can represent sequences in a general way. The general form for a sequence, if we call this sequence A, would be A sub 1, meaning the first term in sequence A sub 2, A sub 3, A sub 4, and so on, all the way up to A sub n. The term before that would be A sub n minus 1. The term after A sub n would be A sub n plus 1, because what we're doing is we're just adding 1 to the subscript each time. So one term before A sub 3 is A sub 3 minus 1, which is A sub 2. One term after A sub 3 is A sub 3 plus 1, which is A sub 4. That's all that notation there is trying to show you. An explicit formula is a rule that describes the nth term of a sequence using the number n. It's like an equation, and you did these in Algebra 1. So if I'm asking you for the nth term, you can use an explicit formula to give you the nth term if you have the formula, and that's what we're about to do right now. So our first example of Chapter 9 is a sequence has an explicit formula of A sub n equals 3n minus 2. And this wants you to find the first 10 terms of the sequence. Well, what that means is you want to find term number 1, and 2, and 3, and 4, and 5, all the way up to term number 10. So you're going to write, for term 1, n would be 1. So A sub 1 equals 3 times 1, because n is 1, minus 2. And what is 3 times 1 minus 2? 1. For term 2, you're going to write A sub 2 equals 3 times 2 minus 2. What is 3 times 2 minus 2? 4. And then what's my next term going to be? What am I going to write for my next term? A sub 3 equals 3 times 3 minus 2, which is 7. Do you see the pattern? It's just adding 3 each time. So that means that my first 10 terms are going to be 4, 7, what? 10. Yep. Okay. How many are we at now? 9-ish? Oh, you said 28? Okay, sorry. Does that give us 10 terms? Okay, so then that's the answer. Now notice, what did we see was happening after we did these first 3 right here? Our terms were changing by how much each time? 3. Look at this equation. If I wrote this as y equals 3x minus 2, what would you say? The slope is 3. And no kidding, we're changing by 3 each time. That makes sense, okay? This formula right here for this sequence is a linear formula. So it makes sense that we're changing by 3 each time. This is called an arithmetic sequence. We'll talk about that in a little while. But so once you realize that you're dealing with an arithmetic sequence, or once you realize that you're dealing with a linear situation, or after you do a couple of these and you see that the pattern is we're increasing by 3 each time, then you don't have to do this anymore. you can just write out the terms of the sequence very easily. Okay, a sequence has explicit formula a sub n equals 12n plus 3. Now I'm just asking you for the 12th term. I don't care about the other ones. All I want is the 12th term. Just plug in a sub 12 equals. Good. So we get, yeah, 12 times 12 is 144. Plus 3 is 147. So with that formula, if I want a specific term, it's very easy to come up with that specific term. The number here is n. The nth term is this equation right here. So all I got to do is substitute 12 in here to get my notation, and 12 in here to get my answer. Okay, back to patterns here. We want the pattern below, and then describe, so worry about the pattern first. Then describe how to find how many squares are in each figure, and then I want to know how many squares there are in the 100th figure. So I'm not asking you for the number of squares in the 100th, like bottom row. I'm asking you for the total number of squares in the 100th figure. So first let's talk about the pattern. What do you see? Like in general, what's happening from the first figure, which is this one, to this one, to this one? Okay, it's getting bigger. What do you mean by it's getting bigger? Well, how is it getting larger? But why? In what way? You're going way too complicated for me. How are we changing from here to here to here to here to here to here? Where? We add another row. But you didn't say that. We add a row. So how many rows are there in this first figure? How many rows in the second figure? How many rows in the fifth figure? How many rows in the nth figure? N. Okay? So it's important to realize that that's the pattern that's going on. We have one row in figure 1, 5 rows in figure 5, 6 rows in figure 6. That means we're going to have n rows in figure n. So now we can take a look at how many blocks are in each row. So in figure 1, how many blocks do I have in that bottom row? 1. In figure 2, how many blocks do I have in that bottom row? In the bottom row, 2. And in figure 3, how many blocks do I have in the bottom row? 3. So in figure 5, how many blocks do I have in the bottom row? And in figure n, how many blocks would I have in that bottom row? N. Okay? So the question says, what is the pattern below? We are going to have to write something. We're going to say that we are doing what each time? Adding a row to the bottom. So the answer for that first one is add one row to the bottom. Describe how to find how many squares are in each figure. Well, we know how many squares there are in the bottom row of each figure. It's just the figure number. If we're on figure 62, then there's 62 squares in that bottom row, right? But how am I going to figure out how many squares there are in each figure? That means the total. We can use the same thing. Yeah. This is, again, the n times n plus 1 divided by 2 thing that we developed when we added up all the numbers from 1 to 100. Because in this figure, we have 2 and then 1. Then we have 3, then 2, then 1. Then 4, then 3, then 2, then 1. Then 5, then 4, then 3, then 2, then 1. Which means in the 6th figure, we'll have 6 in that bottom row, 5 in the row above it, 4, and then 3, and then 2, and then 1. So whatever figure number we're on, basically we're adding up 1 through that figure number because that figure number has that number of squares in the bottom row. So describe how to find how many squares are in each figure. Put down some sort of words that involves this. You're going to say something to the effect of add up all the blocks in each row, like this row has 1, this row has 2, this row has 3, and so on. Then add all those numbers together or something like that. The shortcut is going to be to use n times n plus 1 divided by 2 to give you the total number of blocks in any figure number. So in this case, we have how many squares are in the 100th figure? Well, that means we're adding up all the numbers from 1 to 100. What's the answer? 50-50. So that's part 1, part 2, part 3, 5,050. How did I get 5,050? We are in the 100th figure, which means we have 100 squares in the bottom row, which means the row above that has 99, and then 98, 97, all the way back down to 1, which means I need to add up 1 through 100. We've already done that. We know the answer is 50-50. Okay, we need an explicit formula for this sequence that I'm giving you. I'm telling you it's a sequence. We need to write an equation that's going to give us this formula, and then I want to figure out what the 20th term is. I could right now probably figure out what the 20th term is. I just got to see the pattern and then just write down terms until I get to the 20th term. The better thing to do is to come up with the formula. It's usually faster, and then you can get the 20th term from the formula. Do we remember how to find the formula for an explicit sequence? The explicit formula for a sequence. We're going to have an n in there, yeah, and we're going to have a sub n equals, and then something in terms of n. So we want to look at what the pattern is here. Just try some stuff. Or maybe you see the pattern already. You got it?
5, 7, 9, possession, 11, 13, 15.
No,
What?
that's not it. There is definitely a pattern here. You just got to spot it. Once you spot it, it's going to be obvious.
Yeah, because
I can tell you the next term. What is the next term? Using your pattern.
11?
No.
No, so 35.
35 is the next term. What was the next one after that? 48 is the next term. What's the next one after that? 63 is the next term, yeah. So you're able to get the terms, but you're not using the correct pattern. Which means that what you're doing isn't quite right. Look at those numbers that we just listed. 0, 3, 8, 15, 24, 35, 48, 63. Okay, so we see even, odd, even, odd, even, odd. That's cool. What else do we see? I can keep going. 80. 99. 120. 143. I'm able to do this quickly because I know the actual pattern. Not because I know it because I'm a teacher. Because I know it because I see it. All of these numbers have something in common. Look at the numbers as a whole.
Oh, 3 goes into 15.
No. It's super simple. It's simple. The thing that they have in common is simple. I can't give you any more clues than that without giving it away. It does have something to do with a power. Huh? Squared.
Oh, you take like the number in the term and then you multiply it by 3.
Nope.
So like this. Yes.
We're getting close though. That's not right. Getting close. What's this term number? 1. And we have 0. What's this term number? 2. But we have 3. What's this term number? This is term number 3. But we have 8. This is term number 4. But we have 15.
N minus 1 times 3.
No. But I like that you're trying. These numbers all have something in common with the term number.
What's the term number?
Mm-hmm.
N minus 0.
These numbers are 1 less than what?
That number times
1 more than 0 is 1. 1 more than 3 is 1 more than 8 is 1 more than 15 is. What are these numbers that you're telling me? 1, 4, 9, 16, 25, 36, 49.
So the term squared minus 1.
1 less than
The square
n squared. Yeah. N squared minus 1 gets you the terms in the sequence. So I can write a sub n equals n squared minus 1. And now that I know that, I can easily find the 20th term. A sub 20 equals 20 squared minus 1. Well, what is 20 squared? 400. 400 minus 1 is 399. There's your answer.
So simple.
Yeah, once you know it, it's easy. You can see it now. These numbers are 1 less than perfect squares in that sequence. Okay, your graphing calculator can be used to perform what's called an iteration. You may have heard that word before, maybe not. But an iteration is just repeated application of the same pattern over and over and over again. Kind of like a person working on an assembly line. They take the thing off the conveyor belt and they put it on a different conveyor belt. And they do that for 8 hours straight. That's an iteration. You're just doing the same thing over and over. So you're repeatedly applying a pattern in an iteration. In the example below, you have your calculator compute each month's balance as an iteration. So let's take a look at the problem first and talk about it, and then we'll worry about what the calculator says. So Pierre began the year with an unpaid balance of $300 on his credit card. So he went out and he bought a guitar or something for 300 bucks. Okay? Because he had not read the credit card agreement, because he was a college freshman and he signed up for this credit card to get a free t-shirt that he never wore because it was a terrible t-shirt, and then he never bothered to read the credit card agreement because he was a college freshman and he didn't care about that stuff. All he cared about was that he had a credit card so he could go buy a guitar. He did not realize that the company charged 1.8% interest. I don't know what company charges 1.8% interest, but if you find a credit card company that does that, you probably want to get that credit card each month on his unpaid balance. In addition to a $29 penalty, in any month he might fail to make a minimum payment. So if you don't make your minimum payment that month, they're going to charge you $29 just for not making the payment. It's important that you understand how credit cards work. Pierre ignored his credit card bill for 4 consecutive months. Amazingly, he didn't have people knocking down his door to collect the money. But anyway, he finally decided, I like this word right here, decided to pay off the balance. We want to calculate what the balance was after the 4 months that he didn't pay. Now you need to realize that the $300 every month is going to get hit by the 1.8% interest. On top of the fact that he didn't pay the bill that month. So he's also going to get slapped with a $29 penalty. The following month, his balance is going to be this $300 plus the 1.8% that he got charged in interest plus the $29 penalty, and then it starts over again. Whatever that balance is, another 1.8%, another $29 penalty. Okay? It's good to be in the credit card business. That's right. It's bad to be in the spending money on credit cards business, just in case you were wondering. So, what we want to do is set up this problem on a calculator, because the calculator will do this problem for us very nicely. Otherwise, we're going to be sitting here and going, okay, we got $300, so then I'm going to have to multiply 300 by 0.018 to get the amount of interest, and then I'm going to have to add that to $300 to get my new total, and then I'm going to have to add that to $29 to get my actual balance at the end of that month. Then that balance will carry over, whatever it is, times 0.018 for the interest, plus whatever I had for this, plus the $29 that I didn't pay, and now I have a new balance. You see how that problem can take forever? Especially when we get down to this part here, how long until Pierre's balance is more than $1,000? We're going to use a calculator to do this problem much more simply. So let's get our calculators out. Okay, so we have our calculators out, and what we're going to do is we're going to enter in the initial balance first. So what was our initial balance? 300. So we type in 300. If it'll let me. There we go. And press enter. We want that to be an answer that is stored in the calculator so that we can use then the answer function that's on the calculator. So now what we're going to do is we're going to take that 300 and multiply it times the interest, right? So instead of typing 300 and instead of going up and selecting the 300, there's a button on the calculator down here. It says ANS. It's right above the negative sign. If I press Control and then the negative sign, it gives me that ANS, and that stands for answer. And what it does is it says, this ANS tells the calculator to take the last answer that we got, whatever it is, and use it right here. You'll see why I'm doing that here in a second. Now, what are we going to do to the answer that we're looking at, that $300? First, we've got to multiply it by, so we'll type in times the decimal version of that interest rate, which is 0.018. You got to move the decimal 2 places to the left to convert from a percent to a decimal, right? Okay. Now, we're not going to pay the bill, which means we're going to get slapped with a $29 penalty. So here is the amount of interest that we're going to get charged with. What do we need to do with that interest? This is the amount of money they're going to charge us in interest. So we have to add the previous balance back onto it. So I'm going to go plus, but I'm not going to type 300. I'm going to type answer again, because I want to use whatever that previous balance was right here. Okay, so now what we're sitting at is the new amount of money in the account. We have the $300. We've added on the amount of interest that they're going to charge us. And now we're not going to pay our bill because we're not smart. So we have to do what? No, we're not going to pay the bill. So we're going to add $29. So plus 29. Is that everything for that month, that first month? Yeah. So now we can press enter, and it gives us our new balance. Now the nice thing is, press enter again. What happened? It did the next one for us. It repeated our previous entry, and our previous entry had answer written in it. So the previous entry comes down here, and now the calculator sees that answer. So instead of pulling the 300 that it used the first time, it pulls the 334.40 that we got in our last answer. What if you pressed enter again? So that was the first month. We bought the thing. After the first month, we got charged $334.40 in our account. After the second month, $369.42. After the third month, $405.07. Does it say 3 months? It says 4 months. So after 4 months, we bought the thing. After 1 month, we're here. After 2 months, we're here. After 3 months, we're here. So after 4 months, $441.36. So now that $300 guitar, because of our foolishness with the credit card, cost us $441.36. Not a very good deal. Great deal for the credit card company, though. So now let's continue. That was 4 months. Down here it says, how long until Pierre's balance is more than $1,000 for that $300 guitar? So we just keep going. We have 4 months right now. Press enter again. 5 months. Oh, sorry. Thanks. So come over here, press enter. That's 5 months. 6 months. 7, 8, 9, 10, 11. There's 12, 13, 14, 15, 16, 17, 18 months. Lost my pen. 18 months. Now, is that a good idea? Your $300 guitar, first of all, turned into a $1,000 guitar in 18 months. That's not good. You don't want that. So that's why credit card companies exist. They make money off of the interest. They make money off of you not paying off your balance right away. We could take this problem a little farther and say that actually we are going to start paying off the balance, but we can't afford to pay all of it at once like Pierre did, because he said he's going to decide. He just decides to pay off the whole balance here. So he's paying off $441.36 all at once. But maybe Pierre decides that he's just going to pay off the minimum payment every time. The minimum payment on this might be 20 bucks. And then we could figure out from what we have here as our balance, if he's paying 20 bucks a month, still getting hit by this 1.8% interest rate per month, how long is it going to take him to pay the thing off? So it's easy to extend the problem, and that's real life right there. So this pattern, this iteration that we did on our calculator makes problems like this very easy. But you got to remember how to enter that stuff in. And we entered that stuff in by first typing in our balance and then typing in answer instead of that balance so that it starts the iteration. And then you can just press enter from then on. So practice with that. There's some problems in the homework that ask you to do that. Get some practice so that you understand how to do it, because it does make life a little bit easier. Oh, there's nothing left. That's the whole section.